So the first session, the first episode of this series is just a very quick talk about short notes on academic publishing and its metrics. So this will be our main concern here, although we cannot talk about metrics of publishing without talking about publishing, and we cannot talk about publishing without just hinting towards the cause of the result. Result is the publishing process is just among the results of the cause, and the cause is the research. So we might hint towards the research a little bit. So we'll introduce a big picture, then we will just jump right into the metrics of publication. So we'll introduce few terminology, some concepts, mostly some terms which are commonly heard of among PhD, master students, the beginner researchers. Most of you will already know about this. It will be a refresher for most of you. Some of you, probably very few, will be just wondering about what's the meaning of this confusing terminology and what is exactly meant by that or this. So hopefully by this talk, everything will be clear. I hope so. So the agenda for today is very short. Actually, our main concern is here, as I said, common publishing terms and metrics. But we will introduce to the big picture first, and we will see where does the publishing fit in the big picture. And we'll talk very quickly about the nature of research and why, what, and where we do publication. So these are just very quick hints, and of course, each one of these deserves its own sessions by its own. But we will just make it very short points because we will focus mainly about this, and even this point, we will not be able to cover it in depth. But I hope that if we make it short and sweet, it will be mostly useful for the beginners in particular. First, let's have a look at the big picture. We cannot actually focus on the trees and forget the forest. And the big picture will look something like this. So first, we start and end with knowledge. Doing research is all about making knowledge. So it is the knowledge where we start from and the knowledge where we end. So we start with the knowledge because we learn from what other people have produced. And we end at the knowledge because we want to contribute back to this knowledge. So you start from some body of knowledge, sometimes called body of knowledge. And this will be in the context of a particular field. You cannot handle all the kinds of knowledge that humans produced. So this knowledge needs some researchers to learn and to contribute back. And the production of researcher is actually a long process. And this goes through a formal training. And usually this formal training takes the form of, some degrees like master degree and a PhD degree, and maybe some apprenticeship or mentorship, etc. So through formal training, you will be a researcher. You will be a researcher. And if you are a researcher, your main goal here is to try to add to the body of knowledge, try to produce new knowledge. So it's all about that. So research, by convention, we are talking about the academic research, is all about producing new knowledge. And when you produce new knowledge, you will do research, and in parallel, you want to document that research and all the findings you have done because you want to contribute back to the knowledge, and you cannot convey this one without some kind of documentation. And if you are doing a research and you produce some new knowledge, some findings, and you are doing documentation in terms of writing, for example, of course, traditionally, all the body of knowledge used to be, this is collectively referred to as the literature. And traditionally, the literature was written in a written form. But okay, increasingly, we might see some new forms of documentation of literature, like a narrative literature, for example, and recorded literature like in videos, for example, but this is very early to talk about. But anyway, the body of knowledge in terms of literature, you want to add to that, you write your findings, your new knowledge, and you produce something called the manuscript. So manuscripts have two sides, actually, two aspects. The first and most important aspect is the content, which is coming from the new knowledge. And the second very important aspect is the style of writing, because without proper documentation, this would be much less useful for others. So then the manuscript will be contained in some kind of container. And we call that containers. Sometimes it's referred to as venues, as publication. So you will find researchers talk about publication venues or publication containers or publication types. And we'll talk about that shortly. So, but you cannot just arbitrarily add manuscript to the, body of knowledge without any kind of arbitration. And that's why we usually have kind of filter process. So you need first to submit the manuscript to somebody, some entity that can, it's kind of authority. And this entity will do some kind of review. It will assess your manuscript. And usually this review is performed by some authoritative and some credible people, senior researchers maybe. So these are like guards. These are the guardians of this body of knowledge. So we are going in this direction, but we are doing some filtering in between. So after the review process, they assess your manuscript. It passes. Then it goes through just routine production process, and all these collectively is called the publishing process. Then hopefully it could be publishable, so it will appear in some publication format. And who is doing this publication? A publisher. So we have a term called publisher. This is publishing the publication. So probably the most important pieces for our talk today is actually these parts. So a little bit about the types of manuscripts, a little bit of the types of publication, a little bit of publishers. But we will just hint towards those very fast. I will focus mainly about this publication. There will be many of them, all of trying to pass through towards the body of knowledge back again. So because we will have so many publications really, I mean so many in the scale of millions. So people needed to actually sort these things out and do a kind of ranking. And mainly our talk is about this. What are the criteria to rank publications? What are the criteria? It's formally sometimes called metrics or measures or criteria. And if it is connected to literature, sometimes it's called bibliometrics. So what kind of metrics people use, and we will focus only on the main ones. We don't have time to cover many. So to rank publication and to sort out through these publications and have a sense of maybe the quality of the different instances of publications. So that's the big picture. And probably you sense that we will talk a little bit about this and we will ignore the rest. Of course, the rest are very important topics by themselves. The research process, the writing process, the content characteristics of good manuscript, the style of good manuscript, the publishing process, the review process. But these are topics for further sessions, inshallah. So the next agenda is just a little bit, I will just throw at you just maybe a couple of formal definitions of academic research. So we will just put things in perspective and we will just fix the context and everybody knows what we are talking about. We agree we are all the same page. So just as a first shock, let's just grab some formal definition of a research. But we don't care too much about this. We will assume, I am assuming here, we all have a sense of doing research, or what is the research we are talking about that will appear in a form of publication. So probably we need to detail and elaborate more about that, but we don't have time. We have to omit this for now. For later sessions, we can elaborate more on this. But for now, just please bear with me, and I think a couple of slides would be adequate. So for research, we can say the following. These are some of the recurrent definitions you can find on the net. Maybe we can say it's a systematic and objective form of continuous attention. And this attention is applied to a field of knowledge. And the purpose is finding solutions to a problem or developing some foundational theories. So there is a couple of key points here, systematic and objective. These are very important. Systematic means it's not arbitrary, it's not chaos, it's not randomly. It's systematic means it's planned and it is persistent and consistent and follows some kind of system. That's systematic. So it's not just spontaneous and you come across something, so you research something. Research doesn't happen like that because you need to repeat that consistently and persistently, and that's the word, that's the prefix re is referring to. If you are doing just search, like we do many times actually, if you are looking for job, for example, job search, or you are looking for a product, or you're looking for some commodity. So you do some research. If you do some search, you find your solution, that's okay. But if you're doing this conventional research, you have to repeat that many times, persistently, continuous attention. And this continuous attention is very focused. It's applied to a very specific field of knowledge, and sometimes a single topic and a single problem in that field of knowledge. So the result, again, it's knowledge. What's the solution to a problem? It's a new knowledge. What's the foundational theory? It's a new knowledge. All forms of knowledge. Again, repeat. It's the production of knowledge. That's research. So another definition which emphasizes the art aspect of research, we can say it's the art of investigating new and innovative aspects of some branch of knowledge. Again, it is knowledge. Now, this definition introduces new concept, newness and innovativeness. So now we have said that, okay, the introduced knowledge should be new and innovative. And there is a touch of art here. So there is nothing like very rigid rules that we can apply all the time and we get the result. Although one of the very important characteristics of doing research is reproducibility, but you cannot ignore the element of art in doing research. So enough about that. Now, more concretely, I will just give you a very quick definition of research, which is very, very good and very nice, especially in the context of engineering and doing, computer science, engineering, computer engineering, electrical engineering, all kinds of engineering, really. And I found that on a course on edX. edX is just a MOOC platform, and I like it too much. That's why I wanted to share it with you here. So research is about making knowledge, and research is about aspect. And the knowledge could be some things. For example, just wear the hat of an engineer, please, for a moment. So if you are producing a knowledge, you could learn to do something, and you could learn about something. So what we mean really here is this point. When we talk about academic research, mostly we refer to this point, that knowing something about the world around us. So the research is making knowledge about the world around us, but not necessarily about developing abilities to do something. So like some kind of training, professional training to do something. So knowledge is about the world, can be written down. That's a very distinguishing characteristic. If you learn to do something, it's very difficult to write that down. The ability knowledge, it resides in a person. It cannot be copied and spread around. The other person have to go through the whole process of training and learning, maybe taking many years. But if you discover something about the world, it can be written down and it can be documented. People can refer to this later on. And that's a very, very distinct feature. And I will stop here talking about research. I will just finalize with the one slide. So please bear with me. I know this is not the main focus, but I cannot ignore this aspect. It's very important to pass through the research to reach to the publishing and then understand the ranking of publishing. So this is another slide. This idea is also coming from that course in edX. It's very, very good idea. That's why I wanted to share it with you. So the question here is about the knowledge categories. I said here is that we produce knowledge about the world around us. So maybe a follow-up question is, what kind of knowledge, what kind of things that we can write down about the world around us? So again, referring back to the context of engineering, I think this will be very clear. So mainly the main categories you can think of when you produce knowledge, especially in engineering, I think it's in every other discipline, but if you just wear the hat of an engineer, it will be maybe more clear. So maybe one category is making observations. You are making new observations. So you are observing the world. Of course, when you observe the world, you can observe so many things in the world. You can observe a natural phenomenon. You can observe an equipment. You can observe people behaving. You can observe many things. And you document those observations. Those observations should be new and introducing some new aspect, and should be analyzed and should be able to be analyzed later on and derive something useful from them. Or you can just try to represent the physical world that you are observing in some other kind, in some other form. This is called modeling. This is very, very important aspect for the progress of science and technology. Modeling is very important. Most of the time, we want to interact, we want to understand the world around us. So many, many times, we cannot really interact with the world around us in an efficient manner, in a safe manner, in a cost-effective manner. It's very difficult to just handle the physical world. So what we do usually, we represent the real world, we represent the natural phenomena in some other form, in something else, and then we interact with that thing. So actually, this modeling is actually just a representation of the physical or natural world, any natural phenomena, anything, even an actual equipment, even a person, even a physical phenomena. So you represent that in another form. What other forms? Maybe you build a small prototype, for example. So civil engineers or architects, sometimes they model, real cities with just, some cities from cards. And maybe pilots are trained on some flight simulators. These simulators could be just toys, or could be a real wooden planes in the old days, or could be software. Sometimes it could be just software. So a software that will model the real world, and then you can interact with the software. But most commonly, many people use equations to model the natural phenomena. So we use what is called mathematical models. So this is the most common in engineering and math and sciences. Physicists, chemists, and computer scientists, and all engineers, they use mathematical models intensively. So you just, for example, instead of studying the actual relationship between, for example, distance and time and velocity, for example, or speed, you just say, the distance is the product of time and, speed. That's it. So you don't have to actually measure some distance to know the time it will take you to pass through that distance. Just plug your values here. This is a mathematical model, very basic one, I know, but that shows the idea. So producing new models for different aspects of the world around us is one of the most important types of research. Or this is very also common, a third category, very, very common in engineering, computer science, everywhere, is a kind of methods, is a recipe. You produce a recipe. So you produce a method. You produce a way to solve a problem or to learn something new. And these recipes are very, very important. And maybe if you are a computer scientist, you will talk about, algorithms, you will talk about protocols. Maybe if you are an engineer, you'll talk about device, you'll talk about the mechanism. And etc. So these processes, so kind of new processes, methodologies, these methods also, these are one category of the new knowledge you produce if they didn't exist before. Okay, let's talk about research here, and let's move to the next agenda. So yeah, before that, the next agenda is actually what is not research. So based on what I have just said, probably you can have a sense now of what is not research. I just highlight few points. Just quickly, I will read them out. We will not delve into this, but I wanted to highlight this because this is very, very common among especially new students. Many people, they think these things, these activities and similar activities are doing research, while in fact they are not. Sorry to say that, but it's better to pay attention to this, especially in the early stages. So playing with technology is not doing research, even if you are very, technology savvy and you can deal with so many new technologies. And this is not research. You are just a good consumer, by the way. You are not yet at that level of producer. Assignment work, obviously, even if you are assigned something, probably nobody, very rarely, you will be assigned to do something new. Programming projects is very important. Many people, they produce software and they think that, okay, they produce this programming, they produce software system, so they did a lot of programming, and that's a research. Unfortunately, if that's the research, then maybe a few millions of the programmers around the world will be researchers, and they should have PhD degrees, even if they don't have even a bachelor degrees. Programming projects are not research. They are just maybe a part of implementing some results of research, but they are not research by themselves. Replicating other worlds, obviously, is not research. We are talking about new and innovative aspects. Information gathering, information rearrangement, you know, these kind of activities, studying from books, studying from these are very important activities, very, very important. And but they are by themselves are not research, but they most probably are part of doing research. So most probably these are just steps, and very essential steps in doing research. You have to gather information, you have to rearrange information later on, and you have to study from the literature. But stopping there, you didn't finish. You are not doing research. So you might solve your problem by studying few papers. You found the knowledge, you applied the knowledge. That's it. That's good. That's excellent. But you didn't contribute to the body of knowledge. That's it. And my favorite is this one, because many, especially master and PhD students, spend a lot of time just trying running a software. Most of the time, this software is some kind of simulator. And once they manage to run the simulator, sometimes they spend a few months, sometimes more than 1 year. And voila, that seems that, okay, they have done their job. Unfortunately, this is bad news, but unfortunately, just running the software could be done by some people in a matter of hours if they know about the software. So by itself, running simulation, collecting results, dealing with the simulator, being savvy and very professional in all aspects. Am I back, Ahmed?
Hi.
Did I disconnect?
Oh no, you're online. You're okay. I can hear you.
Okay. So I was just saying that running software by itself is not research. Now the next agenda is quick questions, and we will just pass through this quickly so that we have some time to talk about the metrics. Because we said that this is not research, this is research. So the next question probably is what kind of output that can appear in publications. So what kind of output I can publish. But always, when you talk about what, you first have to deal with why. And just very quick hints towards this. And we will not spend much time. Probably we delay this discussion to a later session. But very quickly, we have many reasons to publish. There are many reasons to do this publishing. Uh, Ideally, you don't want to talk to yourself. If you talk to yourself, you did the research, you produce the new knowledge, and if you didn't document that, and not only document that, sometimes you didn't share also that with others, this will be meaningless. Okay, this could be meaningless. Could be meaningless. So it will be like you are talking to yourself, and if nobody else heard about that, about the findings, about the new knowledge, this is very equivalent to not being done in the first place. So to give meaning to research, you need to publish. And this could be some ideal causes, like, okay, I want to contribute to knowledge back. I want to contribute back to the knowledge that I learned from. I want to contribute to my field. I want my field to progress and to advance. Or I want to serve my community that served me before. So this community could be the research community, it could be the country, and could be the whole world. But please remember, these are very ideal causes for publishing. But be aware that research can also have meaning without publishing. So you don't necessarily have to publish to give meaning to research. Examples of that, case in point, for example, military research or commercial research. Many times, the military, they do R&D. Every company actually does R&D, but they don't always publish there. So they can have an advantage. Either this is a national security secret, or maybe it is a trading secret, so they don't publish it. But still, it has meaning. It will show up in some form, maybe in a form of a weapon or a form of a product, or else. So another reason to publish is just to get feedback. So publishing is a good source of feedback from the peers and from your peers, even in the future. And it is a force, this is a very important one, although neglected many times. It's a very important force to clarify ideas, your ideas as a researcher, and to fit the ideas in the context of the current state of the art, current state of the research. And these are very ideal things. These are very ideal reasons. More practical, pragmatic reasons are these. So maybe it is just a requirement to graduate. So maybe you want to get that degree, PhD degree, and there is a requirement to publish. So you have to publish. Or maybe you just want to promote yourself. Promotion needs publication in your institute, for example. Could be your KPI. To renew your contract, for example, needs publication. So you need to publish for that. Or for credibility and recognition. So you want others to hear you. You want them to listen when you talk. How you can ensure that they will listen when you talk? You have to be recognized by your peers and hopefully by your seniors, and you want to be a credible person in your field. And how do you do that? Actually, one of the main reasons, one of the main means to do that, in addition to uh, uh, actual meetings, uh, lectures, face-to-face talks, you have to also publish something. You have to disseminate your knowledge in a written format. So this will establish you as a member of the research community. This is very important. Those are more pragmatic reasons, practical reasons. They are important, although they are not very ideal as the first ones, but you need them. Sometimes you need to do influence. Influence is also some in between practical and personal reasons. Influence means you make your words to be heard. For example, the organization, the company, the university, the research group, even the researcher who will publish more in a certain field, they will dictate the progress. They will dictate the state of the art in that field, and they will have influence on what's going on because they publish the more. Of course, there are more personal reasons, like for example, you want to have self-satisfaction for prestige, respect. This overlaps with this one, but the motivation for this one is practical. The motivation of this one is more like self-satisfaction. And also sometimes, although it's not very obvious, it's not common for researchers to be rich just by doing research, but maybe direct or indirect financial benefits could be gained from doing publishing, like doing having that degree, having that promotion, having grants, and sometimes indirectly by connecting to the industry, etc., could lead to some financial benefits, although this is not very typical. What to publish? I will ignore this for now, but you can publish new inventions, theoretical foundations, experimentations, implementations, new concepts, new approaches, methods, protocol, algorithm, metrics. You can enhance existing practices. You can do some data analysis. You can analyze or develop models, all these kind of output that comes naturally out of these things, out of this kind of knowledge you want to produce. And remember that you can focus on the data or you can focus on the methods. So you can introduce new methods mainly or improve existing methods, or you can focus on collecting data and analyzing those data, producing new models or new observations, etc. And where to publish, we will ignore this for now. Just forgive me for maybe later on we can talk about that. It will not make a lot of sense because we didn't talk too much about the venues of publication. So let's just move into the other item on our agenda and start talking about common publishing terms and metrics. So let's do it now. So we may have some time to discuss this. Just quick check. Is it okay, Ahmed? Am I on track? Is it okay?
Yes.
For me. Okay, good.
Still
So
fine.
I overlooked to mention that. Please feel free to ask or interrupt whenever you want. Although hopefully we will have some time around after the end of this session, so we can have quick discussions and open discussions, Q&A sessions, quick Q&A, for example, for a few minutes. So coming back to the agenda, so let's just review back the big picture. We heard a little bit about the whole process, especially about this part here, although we don't care too much about that here. So we have to move into this a little bit about this, a little bit about this. So very quick slides, then we can focus more on the metrics of this. So if we start with publication, we have several types of publication venues. Venues means what shape that the publishing content takes. So we have few of them, actually many, but I will focus on the main ones. So the publication, the venue of publication can take the form of a book or monograph. Monograph is just like a narrative by a single person most of the time, talking about a single topic, or the books can have multiple topics, can have multiple authors. Or a journal, This is one of the main types of publication. Actually, from now on, we'll mainly focus on this type of publication when we talk about ranking. So mostly we'll talk about journal rankings. This is one type of publication. And we can have edited book. So if you are producing an edited book, you will collect some individual works from many researchers, and you will make sure that these are according to the standards of your book, and you will edit all these contributions, and then it will be published by many authors. Or you can just a contributor of a single chapter in that book. Or maybe the second most popular venue of publication after journals is the conference proceedings. So these are also kinds of publications, is very common. So mostly students will hear about journal papers and about conference papers. So the individual pieces of publishable units, we call these articles or papers. This could be published here in the journal, or could be published in the conference, or can take the form of a chapter that will contribute to the edited book. And of course, later on, maybe you can produce a book which is contributing some established knowledge. Most of the times, these books, the material of these books coming from journal articles and conference articles after they are well established and verified and proved. Or we have also other kind of publications, of course, but this is mainly outside the academic world. So we mainly focus on academic. We have, for example, technical reports, white papers. These are produced by the industry. And also we have something called trade publication, trade magazines, for example, and also produced by the industry. Trade magazine, our trade journals, are actually trade here is taking the meaning, not the commercial, but the meaning of a profession, meaning of a job. So some companies or some kind of industry, single industry, many companies within that or organizations within that industry, they will have their own trade magazine or trade journal. They will share information about their products, job listings, for example, announcements, etc. And if you open one of the databases, some services website we'll talk about later on. This is called Scopus. Scopus is one indexing service we will talk about shortly. You can find that whenever you search for sources of publication, means different types. These sources, this is a tab talking about different types of publication. You can find these listings of journals, book series, conference proceedings, trade publication. These are the main publication types listed, indexed by the Scopus indexing service. So we will focus more about journal, bear in mind. So we will bear journals in mind. But let's clarify conferences a little bit, because I said that these are the journals and the conferences are the most common venues, especially for students, for PhD and master students and beginning researchers, before you are able to produce books, for example. So for conferences, you just clarify this in a single slide and forget about them. They are very useful for quick dissemination of your research. So you have quick results, quick dissemination. You want to just, maybe you want to just prove that you are the first to produce this kind of idea. This is a good candidate, a conference. These are repeatedly organized all over the year by many institutes, many organizations, many companies, many colleges now even. In some areas, the impact of a conference paper is more than the impact of a journal. This happens especially in computer science. Usually, the common convention, the common perception is that journals are more prestigious than conferences, but sometimes it's not the case. In some areas, especially computer science, conferences are more prestigious. So many people first try to publish in conferences, then after that, maybe they reproduce their work in journals. And this is very obvious in the series of ACM, for example, conferences. ACM is the organization that is, equivalent to IEEE in engineering. And conferences provide an opportunity to verbally communicate and follow up discussions. That's a human communication. And this is one of the most important aspects. And it helps explore new thoughts. You can have a lot of ideas if you attend these conferences. And of course, one of the most important aspects of and benefits of conferences is this: facilitating the interactions and networking. Networking is a very key word here, very important keyword, with peer researchers. This could be peer researchers, candidate collaborators, candidate employers, etc. The journals are archival in nature, in contrast. So archival means this used to be like an archive for the knowledge. So that will form the main container of knowledge, body of knowledge we talked about in the beginning. So the length of the papers are usually longer than conferences, and they are also expected to be more rigorous and more mature. The journals, I mean, the journal papers, journal articles. And also there is another side effect of this, that the turnaround time means to check between the submission and the filter. You remember that publishing process. So this is much longer. The turnaround time between submission and the publication is usually long. It's not fixed. There's no hard rules. Could be months, could be year or more. But one of the reasons for this long process is the process of peer review. Peer review is, unlike conferences, is much more rigorous, and usually your article will be checked and assessed by a few reviewers, peers. But we'll not talk too much about that because this is another topic by itself. Just a fun fact that the first academic journal was this. I will not even dare to pronounce it. It was in January in this 17th century, 1665. So we are talking about an industry a few centuries ago, few centuries old. And it was followed immediately by this philosophical transaction of the Royal Society in March of the same year. Okay, so what about the articles? What about the manuscripts? We have also some types of these, including a research article. This is the most typical ones. Is the form that whenever you have new knowledge produced, most of the time you can write this in the form of a research article. You explain your new knowledge. Or could be very short one, very shorter version of this. So it is called a letter usually. And this is just if you really want to disseminate knowledge and very fast about a very recent breakthrough, and you don't have the time to complete all the experiments. So maybe you can share your results initially in a form of a letter. Could be a couple of pages only. Or could be review articles. These are very important to establish the knowledge. You are just summarizing and sorting and analyzing the existing literature, and helping yourself, helping all the other researchers, getting an idea of what is going on in a certain field. Or could be case studies, certain projects, certain studies, and you elaborate on that, share the details on your experiences on that. Or could be introducing new methods, or could be nowadays is an increasing trend of doing just paper about data, about your data, not the method, not the idea, just the data you use to produce the idea or to highlight the idea. And finally, you can have editorial papers. These are written by the editors, the editor board. Usually, this is the opinion of the editor board of a journal, so you don't have a contribution to that. So we will assume now we talk mainly about research article in a journal publication. So very quick note about publishers, just to finish this out. To finish this part, I talked about here previously, these three blue buttons. Okay, the publisher, the publication, manuscript. We still have to talk a little bit about publisher, just to put everything for completeness only. So very quick notes. I will just read them out mainly. So this is mainly taken from Wikipedia, so you can refer later on to this link if you are interested. So in the 1960s of the 20th century, the last century, 1960s, 1970s, they existed commercial publishers. Okay, these are new business now is forming. New commercial publishers began to acquire the best journals. The journals before that used to be published by non-profit academic societies. So like you remember this one, the Royal Society that produced this transaction. So later on, we had some commercial companies doing this. They acquired these journals that was published by non-profit, so they are becoming for-profit. And there are thousands, actually, more than 2,000 of publishers, but really five for-profit companies, namely Elsevier, Springer, it used to be Springer, now Springer Nature, Wiley, Blackwell, Taylor and Francis, and Sage. These are the big names, the big fishes. So these are responsible for nearly 50% of all the published articles. And some data indicates that these companies have profit margins of around 40%. This profit margin is more than any profit margin in other industries, which are profitable. So it's a very lucrative industry indeed. So unlike most industries, publishers, like those companies, they get the two most important entries, the most important raw material, of academic publishing, almost for no charge, almost free of charge. So they get the articles for free, and they get the peer review process for free. It is voluntarily basis, and then they sell the product. So this is very lucrative indeed. But this is a long debate, and there is a much debate going on about this model of publishing. But this is outside the scope of this topic of this session. Now is maybe we come to the meat of the talk. So this I will focus maybe in the remaining 10 to 15 minutes about this, just merely about this. So what's the idea of this metric? I mentioned in the title the word metrics. Why do we need metrics or measures or criteria? Actually, just because we want to rank journals. If there are so many journals, thousands of publishers producing a lot of journals, millions of articles, how to sort this out, how to go through this, and how to have a sense of the quality of this huge amount of production. So the journal ranking is widely used in academic circles to evaluate the impact and quality of an academic journal. So we have journals. We want to have an idea about what impact and what quality this journal has. We assume we are academic circle. We are not industry. We are academic circle. So we want to use just this measure, this kind of evaluation metric. So we call this ranking, as you know, ranking is very common in everywhere else. Traditionally, what used to be done, actually academic institutes like universities, for example, they used to evaluate and rank the journals, whether their journals or the journals produced by other institutes, using panels of their experts. So they will just make use of some experts. They ask them to evaluate the journals and give some feedback, and they will just, approve that. So, but this method has suffered from some problems. Politicization, policies means politics, biases. I am from this industry, you are from that industry. So the journals coming from the industry, the journals coming from the institute of an opposite opinion, opposite stand could, for example, could affect my evaluation. And also, very important problem, there is a wide disparity, wide difference between the evaluation between different institutes, because these are different peoples. So maybe two journals evaluated by two institutes, one is very good, one is very bad, although they are very similar in quality, because the people are different in two institutes, the people who did the evaluation. So the quality of journals can be now evaluated in another traditional way. There is another traditional way, through surveys. Maybe you can send survey, like a questionnaire for all the experts from different institutes. So this is also possible, especially from prominent academics in a particular field. But still, this method shares some disadvantages with the first method, but less severe than the first one. But people look for a better solution. So actually, the attention since the 20th century, the attention has shifted to searching for a set of bibliometrics, kind of metrics related to publication. So this is called bibliometrics. So we want a set of bibliometric metrics or scales at the level of the journal, so that measures the journal performance, which can be used as a measure of quality. And we want to eliminate the need for self-evaluations, like by experts, individual experts. And what happened that researchers have proposed several journal level metrics. Journal level means I am evaluating the journal, not the individual articles, not the individual authors, just journal level. So they have proposed, many people propose metrics, most of which, actually, there is a common characteristic among all the metrics proposed, most of which are based on the concept of citations. Because it's really difficult to assess the quality of a research work. So most people just take something external, which is the received feedback of that piece of work. Citations means the mentions of your work of a journal article. Okay, if some journal article is mentioned by other researchers in their future work, so means these are mentioned in their references lists, in their bibliography. So in the reference list, you find some article from a journal, like journal A. So you refer to all the articles, for example, many articles, and you see what is the journal that was mentioned Recurrently means many people mentioned articles from that journal, because one journal publishes a lot of articles. So these are called the citation. So you add one mention is one citation, two mentions, two citations, etc. So this is the main vehicle people use to assess the quality of journals nowadays. And there are many metrics, but we will talk mainly about two for now. Mainly about two, but we introduce a lot of, depending on the time. If you have a look, I give here actually a link produced by Elsevier, one of our publishers, if you remember. And this link will open. Hopefully, it can open. Let me just check if I can open this. This is a document by Elsevier. It's called Research Metrics Reference. This is just to give you a very high-level, a quick review of all the kind of metrics that exist. There are many of them, really, but we cannot cover all of them. But if you want to you go deep into that, probably you can refer to this document later on. So this is produced by Elsevier, again, and some of the metrics mentioned here, some of the ways that you can measure the quality of journals. Most of them, again, most of them depend on, the citations. For example, citation count, very direct. Document count, okay, less direct, but it is depending on the quantity of the papers. Something called field-weighted citation impact, again, about the citations, but with some flavor. H index, this is related to individual authors, how much citation they get, but then the authors, you collect all the authors from a certain journal and how many citation they got. There is something called site score. We'll talk about that shortly. Something called SJR, Sky Mago Journal Ranking. Also, we'll talk about shortly. We'll just select a few of them and we'll shortly introduce them because these are the most common ones. Something called SNP, Source Normalized Impact per Papers. These are actually site score, SJR, and SNP are produced by a single organization called Scopus, including H index also. And there is another organization called, another organization we'll talk about shortly now, next slide, called Journal Impact Factor. This is the most prestigious metric, and many people use this nowadays. So this is also another one depending on the citations. And there are other metrics, so you can have a look at that. And nowadays we have also metrics, alternative metrics, like referring to the social media, for example. These are all referring to the same thing, how we have a sense of the quality of the journal at the journal level, and mostly based on the citations. But how we calculate that, how we quantify that, how we turn that citation into a single number so we can compare between different journals. That's the idea. That's the meaning of a metric in this sense, in this context. So the bibliometrics we talk about are these. These are just statistical methods to analyze the books, articles, and other publications, but we focus most on journals. Okay, and there is a subfield of bibliometrics that is concerned with analysis of scientific publication. If it is about scientific publication, this could be called scientometrics. And mostly it's all about citation analysis. So this is a commonly used bibliometric method, mostly about citation. So we analyze the citation. Now the question, who does that? So of course you can refer later on to these points. I'll just make it very quick notes now, but we'll focus more on the metrics now, just for maybe the remaining 6 or 7 minutes. So you can refer to this later on. But the point here is that we care about citations and we analyze citations. Analysis of citations is not easy. So we need somebody who is specialized in this thing. And we need somebody who can take this citation and even sort them out. Sort them means rank them. So order them so that we can have an idea about the order of quality of journals. So from that, there is a new concept called indexing of citations. So indexing of citations, initially it was just for retrieval of information. Means I index a citation, means indexing means mention in some kind of database. Just mention, list them out. List them in a kind of database. So you are indexing. Indexing means there is a list. There are many papers, many journals, sorry. And if you include the name of that journal in this list, means you are indexing. You are mentioning them in the index, so you are indexing this journal. And this will be your index. And this is just a kind of database. If you add them, you are indexing them. Do you add anybody? No. It depends on your criteria. It depends on your quality standard. You might have selected some of them. Most probably, you will select some of them. It depends on your criteria. So this index is very important because you have to also offer some kind of analysis to all these citations you get. Because you mention these journals, you study the citation they get, you order them, you analyze this citation, and you share the result with others. So who is doing that? We need, for this citation index, okay, we need something called citation indexing service. So there are actually many citation indexing services, but very, very few that are very, very common and very popular and very prestigious. So these are services, organizations, or companies doing this service. What service? Indexing and calculating, analyzing the citation. If I go back to this slide, citation index, the database you are building, is a type of bibliographic index. Citations are just indexed between publications, making it easier to identify later documents that cite earlier documents, means mentioning them in their reference list. There are a lot of details here, historical details, but you can refer to this later on. The main idea here is that one of the most important, this idea of citation index actually is started from somebody. There are many companies now doing this citation analysis, but actually the original idea came from this scientist called Eugene Garfield. This guy founded the Institute for Scientific Information. He founded an institute. That institute is called Institute for Scientific Information. This is abbreviated as ISI. And this ISI you might hear of frequently. This is the original institute founded by this guy and using the idea of citation analysis. And this ISI institute, this was formed in 1956. It was aimed to provide academic publishing service, especially analysis and indexing of citations. That's the business. That's why up to this point, it's the most prestigious one, the most important one. So, but it went through many stages. So eventually, for example, in 1960s, this ISI Institute introduced its first citation index for papers published by academic journals. And this index, this kind of database, first index, this was called Science Citation Index, SCI. So you will hear sometimes this SCI. This is one type of database produced by that institute, ISI. So it includes one kind of papers, some fields, some scientific papers in some scientific fields. Then they have added also Social Sciences Citation Index, SSCI. And then later on, Arts and Humanities Citation Index, so AHCI. So there are actually many indexes. When we talk about ISI, and we talk about, there are actually many collections of indexes. It's not a single index. SCI and expanded SCI, SSCI and AHCI, etc. And then these indexes evolved into what is called Web of Science. And this Web of Science was managed by something called Thomson and Reuters, then later on purchased by something called Clarivet. Clarivet Analytics is the more recent company that acquired this kind of institute, and now they are managing this citation analysis under the name of Web of Science. So there are other services like Google Scholar and Scopus, and we talk. Maybe I have some time to just review just maybe the most important one, which is the Web of Science and the Scopus. So Web of Science, again, this is originated from the ISI indexes created by Eugene Garfield. This is now owned by Clarivet Analytics. This is the company that owns now this. Means they are performing the analytics, they are publishing the results, and they are selling the results. Formerly, it was with the Thomson Reuters. And Scopus is owned by Elsevier. So again, this is for profit organizations. You have to remember that these are commercial services. And both are based on subscriptions. Maybe important to notice that they are vary greatly in cost. Both are selective, means they have some quality, but generally speaking, WOS, Web of Science, is considered more selective, means it's harder to get indexed by a Web of Science index, one of the indexes in Web of Science, than getting indexed by Scopus. Means the standard of Web of Science is a little bit higher than the standard of Scopus indexing. That's why you can find around half or less a number of journals in Web of Science indexes than the journals in the Scopus listings. There are free services like Google Scholar. There are some specialist services like Medline, but we will not talk about them. So for Web of Science, this was previously known as Web of Knowledge, if somebody is old enough to remember that. This is just a website. Actually, the Web of Science is a website that provides you with the access to these databases, the indexes we talked about. Actually, there are many of them, as I said. There are many of them. So there are something called Web of Science core collection. So you have many databases, many indexes, not only one. So I will ignore some details. You can refer to this later on. This is not the main focus. I will focus on the main important details, and then later on, after discussion, if you have time, if you want, we can get back to this. I will just share with this information with you later on. So the most important part to remember is that the Web of Science has a core collection of mainly 6 databases. So you have, for example, the main ones. Now people sometimes, they are getting indexed. Some journals getting indexed in something called ESCI, and they say we are ISI indexed. Actually, not so really, because if some journal meets the quality criteria for a certain level, so Web of Science, they have many collections. One of the new collections is called Emerging Sources Citation Index. This is the name of a new kind of index, new kind of database. This is not really at the same level of the most established ones, like what we talked about, like SCI or SCIE. SCI, remember, the Science Citation Index. This is one of the original databases, or the expanded one. E is for expanded, or the SSCI for social sciences, or for AHCI for the humanities and arts. This is not at the same level. This is just emerging, means they are potential to be added to these most prestigious ones. They are just having the potential, but they are not yet there. So if they meet this criteria, they will be added that. Journals that meet the additional impact criteria, they will enter these more established databases, like Science Citation Index Expanded Index, this database, or the Social Sciences Citation Index, SSCI, or the Arts and Humanities Citation Index, AHCI. This will depend on the subject area, of course. Humanities and arts here, social sciences here, but most of the scientific are here. These are SCI and SCI expanded. These are the most important indexes. Actually, really, those are this one, the journals index here, and the journals index here in these 2 indexes only. Unfortunately, this is excluding the humanities, excluding the arts. Okay, only those databases. They are given a number representing the result of the analysis, and this number is in this case called impact factor. The impact factor is just a summary, one number that summarizes the impact and quality with respect to citations using this Web of Science method. And those impact factors are published every year in a report called JCR, Journal Citation Report. So Journal Citation Report is just a document, a report produced annually, means every year by, the Web of Science means Clarivet Analytics, the organization that supervises this thing. And what is this JCR? Is a listing of papers, and with every paper, there is a single number. This number is called impact factor. So everyone will have an impact factor. And what we do with the impact factors, actually, these impact factors are numbers summarizing the result of the citation analysis. Means they reflect the quality of the journal in terms of citations. And because they are numbers, they can be ordered. So you order them, you sort them from the most, or from the high to the low. So if you have the highest impact factor, this by field, by the way, in a specific field. So this could mean that you are better journal in terms of quality with respect to citations than the lower impact factors. And when you order them, you can even divide them. For example, if you have in a certain field, you have 100 journal with 100 impact factor, and you sort them out from the top to the lower, and you set them out So in descending order. Then maybe you can take the top 25% of these journals. So for example, if these are 100 journals, you will take the top 25 journals. So the highest 25 impact factor. And you can call this quarter one, Q1. So these are the top quarter among these 100. Of course, this can be any number, could be 200. So in case of 200, instead of taking 25, you will take 50, etc. And then you take the next 25%, and you can call this Q2, the third Q3, and the journals with the lowest impact factors, the 25% lowest impact factors, you call them Q4. So mainly Q1, Q4, Q2, 4, these are referring to the quarter of the journal in a listing of the journal citation report based on the order of the impact factor. So of course, this concept also moved into other citation services like Scopus. But really, most of the time, when senior people, especially old people, they talk about the quarters, they talk about Q1, Q2, they are referring to Web of Science collections, means these indexes. Science Citation Index Expanded or Social Sciences Citation Index only. They don't refer to the quarters, orders of the other, other metrics from other organizations like Scopus, because these are the quarters are really bound to the impact factor, and impact factor is from Web of Science only. For Scopus, they have something else. So these are the collections. Expand. This is emerging. Something. Also, they index proceedings, by the way, Web of Science, and books, but they don't get into the journal citation report. Only these two get into the journal citation report. So you can refer to this document later on. I will share this with you. And these are documents coming from Clarivat Analytics. So for the limitation of time, I will skip this for now. But these are very straightforward to understand. This is just elaborating what are the criteria. For example, here, this table showing you the criteria used by the Clarivat Analytics to include the journals in their indexes, in their databases. So there are quality criteria and impact criteria. This is a lot about editorial, about management, about things, formalities, but this is really about citations. So then they produce a number impact factor, and this number is calculated as follows. This is the guy. This is Eugene who invented all this stuff. And actually, the annual journal citation report impact factor is just a ratio. How it is calculated, I said previously, it's just a number. It's just summary that reflects the quality in terms of citation. But how that summary is driven, how it is derived, it is derived by just a simple equation, just a division. A ratio between all the citation you got in certain number of years and all the citation means the journal got this citation, and all the citable items published in the same period. More concretely, the impact factor of a journal is calculated by dividing the number of current year citations to the source items published in that journal during the previous 2 years. So you have citations in the current year. Citations means mentioning of some previous publication. What kind means when I say previous? Is it open in the past? No, only the previous 2 years. Some previous 2 years. You select 2 years. For example, you have 19 in this example and 1991. This is just an example here. So you have some journals in 1992. Now in 1992, now I am calculating the impact factor. I refer to 1990 and 1991. I'm referring to these two. So what citations in this year I got that mentions means citation of papers published in these years. So in 1992, again, I published some articles and they have cited some papers. And those papers only who are published that are published in these 2 years, I will take into consideration. So I will get some number, like for example, B. B is the number of citations in 1992 to articles published in these 2 years, previous years. Okay, that's B. And then I will also look again at 1991 and 1990 and 1991 again, but I will look for not the journals that were cited in 1992. I will look for the number of articles published in those 2 years. So maybe that's C. So I would just divide B by C. That's it. So B is how many citations I got in the current year, 1992, that are citing journals published in the previous 2 years, 1990 and 1990 and 1991, and divide it by the number of published articles in that 2 years, 1990 and 1991. So the result will be a number which I will call the impact factor. And it is this in Wikipedia. You can find this is what we have just said. Citations of the previous year and the previous to previous year, and then the publication of the previous year, previous 2 years. And that's the normal, that's the impact factor. And this is just an example of the Nature journal, which has very high. Actually, most of the time, these impact factors are low numbers, especially in engineering, computer science. These are, from 0.5, 0 point something, up to, for example, 1, 2, 3, 4, 5 is considered very high. But for some fields, like, for example, medicine or chemistry, for example, you can find more than 15, 30. For Nature, for example, this is 41, and sometimes goes even above 100. What about Scopus? Sorry for taking a little bit more time, guys. Is it okay, Ahmed? I am not sure. Is it okay to take a little bit more few minutes?
Yeah, okay,
Anybody
sure.
has objection?
Yeah, I'm good.
Okay, so we have few attendees. So I think if there is any objection, please just say so. Or anyway, we are recording this, but I will just allow myself to take a little bit more few minutes. Actually, we started a little bit late, but sorry for that. So I will review now the metrics by Scopus, and Scopus has more than one metrics. It's not only the impact factor. Later on, you can refer to most of the details I'm listing here. I'm listing more details that I'm talking about. So, for example, some stats about the number of publications, about the number of publishers indexed by these organizations. So, for example, Scopus indexing a lot more than Web of Science, than the Clarivat. So you can find few, like more than 27,000, for example. The titles means different journals and proceedings and books, because they index books and journals and proceedings and trade journals. And they have 3 main types of quality metrics. Okay, we will focus on the main 3. The most important one is site score. This is by Scopus. Second one is SJR. This is also by a third party, but referring to the Scopus database only. And the third one is also third party, means these are not done by Elsevier, but they are still referring to the citations inside the Scopus database. So it's called the SNP. This is from a university in Netherlands, and this is from some organizations called SkyMago. But this one site score is done by Elsevier in the Scopus database itself. But all of these referring to the same data. So you can refer to the links here later on, and you can get more details. So the first, these metrics are listed here. If you open the sources page from a Scopus website, this Scopus website is just an interface to the indexing service. They give you information about all the citation analysis or the indexed journals, indexed publications using this interface. So this is the website, like Web of Science in the case of Clarivat. So you can find here site for each journal. Here are the journals, and you can find site score, a number. You can find the SNP, just a number, and SJR. These are the metrics we are talking about. So for the first one, which is site score, it's very, very, very similar to the impact factor, but a little bit some differences. First, it is calculated based on the number of citations a journal has to the following documents. So it is a little bit wider. If you have a citation from an article or a review or a conference or a book or a data sheet, then it is counted. Unlike the impact factor mainly focuses on articles and reviews only. But here in site score, also any mentions in conference papers, in book chapters, in data sheets, it's also counted. And the window is not 2 years. As you remember, impact factor, it was 2 previous years. Now it is 4-year period. And this will be, again, divided by the same number of published documents of the same type in the same period. So this is very similar to impact factor. And all the data are taken from the Scopus database. All the data of impact factor are taken from the Web of Science indexes. Remember, SCIE and SSCI. So these are the two indexes for impact factor. So for example, just this example is very clear. So you refer to the citations you got in this year out of these 4 years, 2016, 17, 18, 19. Okay. And then this is to calculate the site score for 2020. So site score for 2019. This is another difference. So if you want to calculate the site score of 2019, you will consider the previous 4 years, including the current year. So here, all the citations you got for these 4 years, for the published articles in these 4 years, and divide by all the documents, the documents including these articles, reviews, conference papers, book chapters that were published in these 4 years. And you divide A by B and you get a number, and that number will be the site score. Just another quality metric quantifying the quality of a journal using these calculations. And you remember this is 4-year period. It is updated each year. And it is 4 years. It's considered that the 4-year, okay, they say that the 4-year time window provides a robust assessment of citations to papers after the publication, etc. And the types will be also a little bit more, like articles, reviews, conference data papers, and book chapters. So if you just got these points, now you know what you need actually. So most of the time you will hear just about these two metrics: the impact factor coming from Web of Science, all those indexes, and the site score coming from the Scopus database, a single index. So if you want a quick, there is one very important note about this actually site score and impact factor, which you have to remember that you cannot use these to compare journals in different disciplines. So you have to confine your comparison in a single discipline, single field, because the citations, the impact factors, the site score differ widely among different disciplines. If you want, especially for Scopus, if you want to compare the journals indexed in Scopus from different disciplines, there are additional metrics. For example, you can use the SNP or you can use the SJR. But before that, quick comparison between site score from Scopus and impact factor, journal impact factor from Web of Science, very quick. So in terms of calculation, data source, what is the data? The data here is Scopus index, and the data here is Web of Science database, which are mainly two indexes, SCIE and SSCI. We have seen previously. The calculation window here is 4 years and here is 2 years. And the type of included documents here are more, like reviews, conference papers, book chapters, datasheet, and here mostly articles and reviews. So very quickly, the SNP is introducing a new idea. By the way, SNP is a metric. Is calculated by this. It's just a metric, a number, calculated from the Scopus database, and calculated by this CWTS Center for Science and Technology at Leiden University. This is from Netherlands. So it is not Scopus. It's not Elsevier. It's somebody else. So they have just invented this way of calculating. What's the idea here? What's the novelty in the SNP? Is this from its name? SNP is source normalized impact per paper. Source normalized means we have modified the number to take care of the source, means the discipline, the field. So it is normalized, means it is modified somehow, adjusted, so that we can compare between different fields. So it takes into account the differences between different disciplines, different fields of study. It measures the citations obtained by a journal relative to the expected citation in the journal's field of specialization. So you got, for example, 5, but the expected means, the expected is the average. The average number usually from your field is, for example, 10. So the average citation in your field is 10. So actually your number is half. So you are less than good. You should be 1 or more if you want to be comparable to the similar journals in your field. It should be 1 or more if you are good. But if you are less than 1, means okay, you are less than your similar journals. That's the idea. So the rest is just details. If you understand this, that's enough. So the significance here is that it's based on the fact that the number of citations varies between disciplines. So we try to compare among similar disciplines. So if you have a number, this means this is with respect to your own peers in your own specialty. What about SJR? SJR is also very common. Many people, they refer to the SJR website. So this is coming from another institute. It's called SkyMigo. So they have, this is SkyMigo Lab. This is something called SkyMigo Lab. And they have, this is a lab. This is a link for this here if you want to refer this back. So this lab have produced SkyMigo Journal Rank, SJR. So what's the idea here? What's the novelty? The novelty is that instead of the quantity of citations, now we look at the prestige. So now they include not only how many cited you, but who cited you. What's the prestige of the people or the journals who cited you? So this is a measure of the journal impact as a combination of the number of citations the journal receives and the importance or prestige of the journals from which the citations come. So, unlike the others, like journal impact factor from Web of Science, site score from Scopus, SNP from also related to Scopus, these are called reputation metrics. Okay, but this is called prestige metric, the SJR, because it also cares about, it gives a weight to who you cited you. So it is very similar to the Google PageRank algorithm. So for example, when you have a search for a page, it's not only the keywords, but also this keyword, how much important, because how many other pages, and not only any other pages refer to this page, but who are those pages? Just a quick example. You see this E here have received a lot of citations from many, but all those many are small. So this E is smaller than C. C has a big number. Although C has received input recited only from B, but B is big. B is something very prestigious. So by extension, C becomes important. C becomes large number, 34 here. Although E has received more citations, but from smaller, less prestigious entities. That's the idea of SkyMigo, SGL. This one I will I will let you refer to this back. It's just a comparison between these three. So especially whether they can be checked. There's an important point here. You can check site score, but you cannot check SNP or SGR. Means you can do the calculation yourself of site score or the site score percentile, but you cannot do that for SNP SGR, because remember, these are coming from other companies, not from the SFE. So they have their own algorithms to do that. Okay, last one I will talk about today. Last one maybe the H index. So the H index is an author level metric. That's why we didn't focus too much on that. We lift it to the end, because the author level means it's not the journal level. We are not comparing journal with the journal. We are comparing author with the author. So the H index is an author level metric that attempts to measure both the productivity and the citation impact, means the quantity and the quality of the publications of a scientist, an author, or a scholar, single individual. Of course, this is the idea. This is the ideal concept. How implementations, there's a lot of debate about that. Again, this is for another discussion. So this index, H index, is based on the set of the scientists' most cited papers and the number of citations that they have received in other publications. So it depends on what are the most cited papers of yours and how many citations these publications have received from the other publications. So how it is defined, how it is calculated, it is a little bit complicated, but it is the maximum value of H. H is just a number, such that the given author, of course, this can be extended to journal later on, such that the given author has published H papers that have each been cited at least H times. So you have produced these journals, these papers, these journal articles, for example, these papers, and these received many citations. Maybe, for example, 10, 9, okay, maybe it's 5, 3, 1, 2, maybe 0. It depends. So we are counting what is the number that satisfy this. H papers all have cited by H times. So for example, how many papers received 10? How many papers received, for example, cited at least 10 times? Is none, actually, because there is no, like, this one is only a single one cited 10 times. At least 10 times is only one. So the H papers that have been cited at least 10 times is just this single one. Okay, how many papers that have been cited 9 times? This and this. So this is just means these are just 2 papers have been cited 9 times. But we are looking for the maximum. We are looking for a number that is the maximum. Maximum H that satisfies that H papers cited at least H times. So for example, to make it clear, if I look at, for example, 3. If I look at 3, how many? This number is 3. This is a H. Is there paper 3? Are there 3 papers at least cited 3 times? Yeah, this one is 1. This one is 1. This one is 1. This one is 1. So there are actually 4 paper. Yeah, there are a number of H maximum that are cited 3 times. So, but I need H. I need a number that includes both the number of citations, 3, number of papers. So number of citations, number of papers. So if I say this author has 3 as in H index, this means that he has 3 papers at least cited 3 times. In this case, if I said 4, I cannot say this. Why? Because he doesn't have 4 papers cited 4 times. See, he has this one, yes, this one, yes, this one, yes, but this one was not cited 4 times. So actually his index will be 3. H index will be 3 in this case. Although there are many citations, there are many papers. There are 1, 2, 3, 4, 5, 6, 7 papers, and there are citations up to 10. But the H index is very difficult to rise, very difficult to increase, because you have to have 3 papers. Okay, if you have 4, if you want to get increased to 4, you have to have 4 papers. So this journal should be cited at least 4 times. Now you can have H index of 4, because now you have 1, 2, 3, 4 papers, 4 cited at least 4 times. That's good. That's okay. Of course, I can say 2, because of course there are 2 papers, this one and this one, cited 2 times. But I am looking for the maximum number. So I don't say this H index of this author is 2, because there is also 3, or there is 4 in this case. If this is 4, the maximum number of H is 4. So I give him 4. I don't give him or her 2 or 3. Although, of course, there are 2 papers cited at least 2 times. There are more. But I give the maximum. I cannot say 5, because there are not 5 papers cited at least 5 times. Only 3 papers cited 5 times. So I have the same number. I have to have H, same number. 3 means 3 papers, 3 citations or more. 4 means 4 papers, 4 citations or more. And that's the idea about H index. I hope it's clear. So this was introduced by this guy, Hirsch. That's the name. That's H is coming from his name. It was proposed in 2005, and it is widely used, especially in Google Scholar. In Scopus, you can find it. So that's the end. But before we leave, maybe it is useful to mention that nowadays, in the recent years, there is a trend towards introducing ALT. ALT means alternative metrics, in addition, as a complementary to the traditional bibliometric measures that we have just talked about. So it's not only about citations, it's not about impact factor, it's not about H index, but it includes something about like citations on Wikipedia, discussions on blogs, mainstream media coverage, like in newspapers, for example, TV shows, etc. Cross-references to reference management systems like Mendeley's, mentions in social networks like Twitter, Facebook, etc. So this is a common trend, although, of course, there are many. For example, the Plumix uses images like this to summarize this kind of, metrics as, downloads, feed views, online comments, likes, social media shares, etc. But as you can imagine, we will not discuss this in detail anymore. But remember, as expected, the alternative metrics, these ones have their pitfalls, have the disadvantage, and there are heated debate about this validation. You can just refer to this article as an example of a critique for this kind of metrics. So at the end, I really apologize. It took more than expected, so really sorry for that. But for those who stick around, I beg your pardon. And if there is any question after that, I know it has been a long time. Please just feel free to add, comment, add a correction, or maybe add some question for enriching the discussion. Thank you very much, guys.
Thank you, Dr. Uh, Dr. I have a question.
Yeah, please, Ahmed. Go ahead.
What would be the benefits, for a student or researcher um, using this, the site score or the impact factor? So how do we, what's the benefits and for a student who wants to write a paper? So
Okay, I will refer you to this. uh, there could be, this is the why. Just correct me if I'm wrong. There are ideal reasons. It means uh, the benefits could be an ideal cause. Ideal cause means a noble cause, very noble. Like you genuinely and sincerely want to contribute back to the knowledge or to the field and advance your field or advance your country. Just an example. Some people have also listing here. They list the intellectual, the intellectual luxury. Like some people like to do that. They like the challenge. This is very ideal causes, very noble causes, and very abstract. And this is very it's it's rarely the case, especially nowadays. But they are more tangible. Remember when I said these are very practical reasons? They are more tangible causes and more tangible benefits. Sometimes you just have to. You don't have the you don't have the chance. You don't have the option. You just if you are a graduate student, it depends on the program. Some programs they have a requirement. So if you want to graduate, for example, for a master program with structure A, for example, in our case, this is by research, mostly called by research, master by research in many universities. Many of these programs require that you publish at least one article. Sometimes they even restrict this article to being indexed in Scopus or Web of Science indexes, as we said. So in this case, you have to just simply to graduate. This is a requirement. And later on, you might have to, for example, many people I know personally, and I know this is just by logical extension, many people they just take the step to publish because they want not a promotion, they want to apply for a PhD, for example, in a prestigious university. And many universities, especially overseas, they have this requirement. Whenever they filter your file, your application, and they found during your master, for example, you have published an article, this will increase too much your chances of being accepted, even for a scholarship. So these are practical benefits, pragmatic things. You could have a scholarship in your PhD because you have published in your master. You could have just graduate because you need that for a requirement. Maybe you really sincerely want to publish because you want to share your knowledge. Most commonly also, many people want to be credible, means more to get recognition. This the need for respect and feeling of recognition among the peers. This is driving a lot of people. This could be practical, or it could be just personal reason for self-satisfaction, or it could be practical because if you want a job, sometimes you want a job in industry, it will help that you establish yourself as an authority, especially if you want a job in academia. If you are, for example, later on a lecturer, you want to be promoted to senior lecturer, and publications play a role. If you are working in industry, for example, in academia, in a contract, as in a contract basis, so you need this for your KPI. So many times these are just practical requirements. This is the benefit, which is the practical reason, and sometimes it's a noble cause, a noble reason. But if you think about noble reasons, this is not only what I listed here. Remember this: if you are a student and you get into this practice, even if you ignore these practical reasons, anything else, even if you ignore this, want to contribute, remember this: it will help you too much to organize, clarify your ideas. Many people now, I didn't talk about this today, but maybe I'll talk about this in a later session. I talked about this in previous sessions, actually. Many people, they ask you to write. There is a school of thought nowadays, a school of thought that say, when you do research, please do writing in parallel. You have to do writing, means you have to put the publication in front of your eyes since day zero. Why? because this is not only helping you produce something, it helps you do the process, during the process. It helps you organize your ideas, consolidate your thinking, clarify everything. Especially sometimes you can get also feedback. If you have something written, you can get feedback. If you don't have anything written, you cannot get a feedback. So again, in summary, as a very quick for your answer, it could be practical reason, you have to. It could be noble reasons, but noble reasons are many grades, and this is almost always useful, even if you didn't mean to get recognized, even if you didn't mean to contribute. Personally, it will benefit you. Okay, Ahmed, is that answering your question or?
Yes, understand. Thank you.
Okay, thank you very much. This is just
There are
my
two
opinion. If there
questions.
is any addition,
There are two questions in the chat. You want me to read it?
yeah, in the chat. Okay, I can refer
In
to
the
the
chat.
chat.
Can you check it out?
So first, there is a question from Zahir. What is your view on the research kit, and how can we utilize it for? Yeah, you see, I didn't talk about that again here, but there is another aspect of doing the research, especially with respect to publishing, which is publicizing yourself. Actually, okay, let's face it. Let's face it. Nowadays, this publishing business and research is like a business. It's like another industry. And you know, if you have a business, you have a product, and when you have a product, you know, you need marketing. So that's it. Most of these windows, actually, outlets like social, we have also social media, but for professionals and for researchers. So for professionals, of course, for normal people, okay, means the rest of us, we have Facebook, Twitter, etc. For professionals, mainly we have LinkedIn. And for academics, mainly we have ResearchGate. And there are many attempts, actually. So these are social media, but a very specific scope, only to exchange posts about profession or about academic studies. So in social media, what you are doing on Facebook, actually you are promoting yourself. You want more likes, you want to connect to others, you want to get known. So this is one of the main aspects. You want to get noticed. And this is very similar in this case. So if you are really doing something that you want to be noticed and you want to increase your chances in your career, means you are, for example, instead of conferences, you are not doing a lot of conferences. In conferences, you can connect to people, but you cannot connect to people, for example, through conferences. You can do that. Connections means get your network to increase. What does that mean? Increase your network means increase your acquaintances. You increase your connections to people who could be collaborators, who could be your employers, who could be your mentors, or who could be your mentees, for example. So you want to promote your work, you want people to know, you want to get at this recognition and credibility, because nowadays, I told you, there are millions of articles. There are thousands and thousands and thousands of items. You saw in Scopus, there are around 30,000 journals. So how can people find you among this? You have to actively promote yourself. How do that? Through these outlets, through this social, academic social media, which is ResearchGate. So in this context, from this perspective, yes, you can gain a lot from ResearchGate, because people try to form kind of communities. You get noticed. ResearchGate is doing that, trying to get that, trying to send notifications frequently, trying to get you noticed by others. Always they send notifications and alerts for others talking about research, similar research to yours, connecting to other people. So you are forming a network. This is very important, connections. You are promoting yourself. You are marketing your research, and you are building a whole network. If you want to get noticed, in ideal world, this would be not necessary, but in our actual world, this is really getting more necessary. So without that, because the mere volume, the sheer volume of the publications and researchers in millions, we are talking about scales of millions, it's very difficult to get noticed. It's very difficult to really, so this could help. So ResearchGate is not ideal, but I have an account in LinkedIn. I have an account ResearchGate. I'm not active, but you should be active if you want to get it, especially if you are aspiring a new researcher and you want to get more chances. and you will be exposed, exposed to more opportunities. And it will, the downside, first, it will take some time from you. And more importantly and more severely, you might learn to play the game. And for each of these, same like Facebook, Twitter, there is a game actually. If you want more followers, you can follow some tips and tricks. So there is a game to be played. You can get accustomed to the game, and hopefully not, but many people find themselves just playing the game in ResearchGate, in LinkedIn, etc. Just be aware of that. Be careful, but you can gain some value out of it. This is in summary what's my take on ResearchGate. And for writing and publishing, you can get the chances to collaborate. But for writing by itself, it will not play a big role. You learn writing and doing research by yourself, and through direct connection with your peers. But maybe you get to know these peers from ResearchGate. Okay, another question is, where do you find impact score or other evaluating indexes in a conference? Where do you find the impact score or other evaluation indexes? Okay, if you talk about the impact factor, site score, unfortunately, as we said here, as we said in this slide, sorry, I am going very fast over the questions. Forgive me if I am not elaborating more, but unfortunately here we say these are commercial services, mostly provided through subscriptions. For Scopus, UNITEN is subscribed, so you can just refer to the Scopus website. You can open the sources, same like here. This page, you can just click sources, and then you can search for a title, and you can find the scores, site score, etc. of the different journals. But for the ISI, unfortunately, UNITEN is not subscribed. So you can find whether it is listed in. So there is something called for this. Something called the journal master list. You can search for this master list. So this journal master list, if you look it up in Google, you can find, this will open a website from Clarivat. Clarivat is the organization that taking care of web science. So you can find a search box, and you can search for a journal, and you can know whether it is listed in the journal citation report or not. If it is listed in ISI or not, in Web of Science or not, should I say. But that's it. For if you want to know the exact impact factor or the Q1, Q2 for the ISI listed for the Web of Science indexes, you have to be subscribed. So maybe you can refer to one student, one of your friends in the university that is subscribed. I think UKM, the big universities, UPM, USM, they should subscribe. But for UNITEN, it used to be, but they just withdrew the subscription a few years ago. So for a site score, you can refer to the Scopus. And I hope this answers your question. Is it, Razin? Is it okay? Okay. Okay. For the last question about how publications can improve university rankings. Yeah, actually, university rankings is coming from other organizations like QS, Times Higher Education, etc. So these organizations are doing a similar job for what the Web of Science and indexes and what Scopus index is doing for the journals. They are doing some criteria. They have their own criteria for universities, for higher education institutes. So these criteria are very wide, actually. It's not about citations only. They include, the number of students, international staff, some standard quality, employability, the qualifications of the staff, etc. A lot of things, facilities. It depends. There's a difference between different organizations, different kind of ranking systems. But one of the criteria usually is around research. Okay, how they measure this research. So usually they refer to this citation metrics. So again, for example, QS for sure is referring to the Scopus. So it's referring to the Scopus and not the Web of Science. So they're referring to the metrics from Scopus. For example, the staff in this university, they are publishing in what journals? what their H index, okay, and they are publishing in what journals? Are they indexed? Most of the publications from this university are these in indexed journals, in Scopus, okay. So what are the citations per paper, for example? Getting, of course, in Scopus, referring to the Scopus database. For the average, for example, for the papers produced by the people, the staff working in this university. So they take all this in consideration. What is the citations collected from the people working in this university with reference to the Scopus only? What are the average citation per paper? Are they indexed or not? What percent of papers are indexed? Maybe something else, like something related to this. But if most of the staff doing good job in this university, means publishing in good journals indexed by Scopus, at least for some, and they are receiving a lot of citations, of course you could be indexed in Scopus, but still your citations is low. It's possible. But if your job is good, your paper is good, it should receive more citations, hopefully. So that will be counted as well. So this is just generally the idea. And I think we have reached to the end. Okay, thank you all for attending and sticking to this point. And hopefully we can also meet you again in some session next month. Thank you very much.